In this question, the position time graph for a particle traveling along x-axis is given. The graph is x versus t. We have to figure out whether the statements are true or false. So let's start with each statement one by one. For statement 1, we have to figure out whether the particle is at rest from at t equals to 0. For that, we should look at the slope of the graph. You need to understand that velocity of a particle is dx by dt, and that is slope of tangent of the x versus t graph. So here, if we draw a tangent on the x versus t graph at t is equals to 0, drawing a tangent at t is equals to 0, what we will realize is that that tangent has a negative slope, which means that the velocity of the particle is also negative. Negative velocity definitely means the particle is not at rest, and therefore statement 1 is false. Statement 2. Particle is retarding in the interval 0 to t1 and accelerating in the intervals t1 to t2. For that, let's look at the speed of the particle at t1 and t2. At t1, the tangent to the graph will be horizontal, its slope will be 0, so the velocity will also be 0. At t2, the tangent to the graph will be like this, which will have positive slope, and therefore the speed will also be positive. Velocity is also positive. So if you see, the velocity of the particle goes from negative to 0 to positive. This means that the particle was slowing down from 0 to t1. So velocity was increasing, but the particle was slowing down. You have to understand the speed was decreasing. Speed is decreasing. However, the velocity is increasing. So particle is retarding. Retarding looks at the speed of the particle. And from t1 to t2, if you see, the particle is again speeding up. So therefore, the acceleration of the particle is accelerating. Okay. So statement B is a true statement. Option C talks about the direction of acceleration, which has changed during 0 to t3 only once. So let's talk about direction of acceleration. Acceleration is given by the formula A is equals to A, where is the pen? A is equals to d2x by dt square. Now d2x by dt square is based on concavity and convexity. Concave up graphs have d2x by dt square positive, and concave down graphs have d2x by dt square negative. Now if you look at the graph from here to here in the first region, if you look at the graph let us mark the region as green. In the green region, the graph is concave up. So in that region, what I will say is that the acceleration of the graph is positive. Acceleration of the particle is positive. Whereas in the red region, the particle is concave down. The graph is concave down. So acceleration in this region is negative. So the sign of the acceleration changes once. I hope that makes sense. So statement 3 is also true. So the answer is false, true, true.